Next question is, let set A having the element 1, 2, 3 up to 9 and R with a relation in A cross A defined by AB, ordered pair related with CD, if A plus D equal to B plus C for ABCD belongs to set A. Prove that R is an equivalence relation. We are given the relation that ordered pair AB is related with CD if A plus D equal to B plus C for ABCD belongs to set A and set A is having the elements 1, 2, 3 up to 9s. All these numbers are natural numbers. If we see the given expression, the X element of the first order pair, AB is the first order pair in the relation. This X element is A and B is the Y element. Similarly, C is the X element of the second order pair and D is the Y element. So we have to remember this order. For a relation to be reflexive, because equivalence relation will be reflexive, symmetric as well as transitive, so we have to check if they are reflexive, symmetric and transitive. So for reflexive relation, element should be related with itself. So if we take element AB, so it should be related with itself AB. This implies that as per the given expression, A plus B, this is the A and this is B as per expression, and it should equal to B plus A. Because these A, B, C, D belongs to set A, which are natural numbers, and in natural numbers, commutative law holds. That means A plus B will be equal to B plus A. This is commutative law in natural numbers. So we can write that as A plus B, and this B plus K, A can be written as A plus B. Because left hand side is right hand side, so we can say relation is reflexive. Second is, we have to check if it is symmetric. For symmetric relation, we take AB is related with CD and we have to check whether CD is also related with AB. This implies that as per the given expression, it will be A plus D will be equal to B plus C. So we can write it as, if we change the order, because as we have said, in natural numbers commutative law holds, we can write it as D plus A is equal to C plus B. And because left hand side is equal to right hand side, therefore right hand side will be equal to left hand side, we can also write it as C plus B equal to D plus A. Now, as per the we have mentioned above, this C is the X element and this D will be the Y element of the first order pair, and here A is the X element and B is the Y element of the second order pair. Therefore, we can write that CD is related with AB. Hence, relation is symmetric relation. And third one, we have to check if it is transitive. Transitive relation says that suppose AB is related with CD and CD is related with EF. Then we have to check whether AB is related to EF. This implies that from the given expression, we can write it as A plus D is equal to B plus C, and here C plus F will be equal to D plus E. Now we add these two expressions, left hand side with left hand side. We will have A plus D plus C plus F. This A plus D is added with C plus F and it will be equal to B plus C plus D plus E. Here we see that D is common, so it discarded or cancelled, and another is here C get also cancelled. Therefore, remaining is A plus F is equal to B plus E. Again, we check the ordered pair. Here A is the X element and B is the Y element of the first order pair, and E is the X element and F is the Y element of the second order pair. Therefore, we can write that AB is related with EF. So it implies that relation is transitive. Because relation is reflexive, symmetric as well as transitive, so we can say that given relation is an equivalence relation as proved. Sixth question is, let n denote the set of all natural numbers and R be the relation on n cross n defined by AB related with CD if AD into B plus C is equal to BC into A plus D. Show that R is an equivalence relation. Relation is given that element AB is related with CD defined by AD into B plus C is equal to BC into A plus D. Here A is the X element of first order pair and B is the Y element, while the C is the X element of the second ordered pair and D is the Y element. Therefore, to show that relation is equivalence, we have to show it is reflexive, symmetric and transitive. So to check the reflexive relation, we have to take an element, say A, B, and it should be related with itself. This implies that AB into B plus A, it is equal to, here if we see the above expression, this B plus C comes in product form first and then A into D becomes addition in the later. So we will write it as, this is BA, this is the product form of this B plus A, and then addition form of this AB, that is A plus B. And we know that in natural numbers, commutative law holds for addition as well as multiplication. So we can write it as AB into B plus A. For natural numbers, A into B will be equal to B into A. Commutative law holds for multiplication. A plus B will be equal to B plus A. So left hand side is right hand side. We can say relation is reflexive relation. Second, we have to show that it is a symmetric relation. For symmetric relation, if we take an element A which is related with another element CD, this implies that as per the given expression, it will be AD into B plus C will be equal to BC into A plus D. Or we can write it as, if we change the order, we will have DA, because commutative law holds for addition and multiplication in set of natural numbers, and here we will have C plus B. It will be equal to C into B and D plus A. And because left hand side is equal to right hand side, so we change the sides and we will write it as CB into D plus A, that is equal to DA into C plus, this is B. So this implies that now we have to write into the element form. Here if we see, this A is related with B, so this C is related with D. This C is the X element of the ordered pair, first ordered pair, and D is the Y element of the first ordered pair. So we will write it as CD. It is related with, and this A is having the X element of the second ordered pair and B is the Y element of second ordered pair. So we will write it as AB. Hence, CD is related with AB and it shows that relation is symmetric relation. Third, we will show that relation is transitive. For transitive relation, element AB is related with, say, CD, and element CD is related with element EF. Then we have to show that element AB is related with EF. This implies that using the given expression, it is AD into B plus C is equal to, and then BC into A plus D. While the second relation will give, it is C plus F, CF into D plus E. It will be equal to, now D plus E will be written in product form first and CF in addition form. And then divide the expression with ABCD. First expression will be divided by ABCD and second will be divided by DCDEF. So we will have AD B plus C divided by ABCD equal to BC A plus D divided by ABCD, and second expression is CF D plus E divided by CDEF, and it is equal to DE C plus F divided by CDEF. So on solving, this A and D get cancelled, and on simplifying we will have 1 by C plus 1 by B will be equal to, here this B and C get cancelled, here it is D, so it will be 1 by D plus 1 by A. Similarly, second expression will become 1 plus E plus 1 by D equal to 1 by F plus 1 by C. Now we will add these two expressions. So add, we will have 1 plus C plus 1 by B plus 1 by E plus 1 by D. We add left hand sides, and right hand side with the right hand side we will have 1 plus 1 by D plus 1 by A plus 1 by F plus 1 by C. This 1 by C get cancelled, and also their 1 by D get also cancelled. So we will have 1 by B plus 1 by E, that is equal to 1 by A plus 1 by F, or it is E plus B divided by B, it is equal to F plus A divided by AF, or we can write it as AF E plus B, that is equal to BE F plus A. So using the commutative law, we can write it as AF. This E plus B can be written as B plus E using the commutative law that B plus E is equal to E plus B. So it will be equal to BE into, again we use commutative law and write A plus F. Here A is the X element of the first order pair and B is the Y element of the second order pair, first order pair, and E is the X element of second order pair and F is the Y element of the second order pair. So we can write it as A B is related with E F. Hence relation is transitive, and because given relation is reflexive, transitive as well as symmetric, so it is an equivalence relation. Hence proved.